Hello everyone, hope you are all doing well. I am Vidyashri. In this video, I will tell you an easy method using which you can solve the questions on finding order of a reaction when you are provided with different concentrations of the reactants along with rate of chemical reaction. So all these data will be provided to you in the table form and you will be asked to find order of a reaction with respect to one of the reactant, or you will be asked to find overall order of the reaction. So first of all, let us consider an example and see how we can solve the question using the traditional method or using lengthy method, that is the method which you use for your annual examination. And this particular method which I will be teaching you in this particular video is helpful for you to solve questions in your competitive examinations. So without wasting time, let's directly jump into the question. The question is, for the reaction A plus B giving C, the initial rate of reaction R0 was for different initial concentrations of A and B as given below. So they have given us different concentrations of the reactants A and B, and they have given us rate with respect to particular concentrations of the reactants. What is the order of reaction with respect to A and B? So we have to find order of the given reaction with respect to reactant A and order of reaction with respect to the given reactant B. Firstly, I will tell you how you can solve this question using the traditional method, or how we solve normal method. That way I will tell you. So from this data that is given, I'll write this as 1, 2 and 3. So they have given us concentration of the reactant and rate of the reaction has been given, using which now I will write the rate law for this chemical reaction. Rate law for this given chemical reaction A plus B giving C can be written as rate is equal to rate constant K into concentration of reactant A raised to X, concentration of B raised to Y. I'll denote this equation as star. Now, from the given data, I can write three different rate equations. So I'll write 10 to the power minus 3, which is rate of the reaction, is equal to rate constant K, concentration of A is 0.2 raised to X into concentration of B is 0.5 raised to Y. I'll denote this as equation 1. Similarly, from 2, I can write 2 into 10 to the power minus 3 is equal to K, concentration of A is 0.2 raised to X, 1 raised to Y. This I'll write it as equation 2. Similarly, I can write 1.8 into 10 to the power minus 2 is equal to K, concentration of A is 0.6 raised to X, concentration of B is 1 raised to Y. Now this is equation 3. So using these three equations 1, 2 and 3, now we shall find order of the reaction with respect to A as well as B. Firstly, let us find order of the reaction with respect to reactant A. In order to find the order of reaction with respect to reactant A, we shall choose any two equations from the three equations that we have formulated from the data, such that in those two equations, the concentration of B should be same. So if you check with equation 1, 2 and equation 3, you can see that in equation 2, concentration of B is same. We shall divide equation 3 by equation 2. So you can write 1.8 into 10 to the power minus 2. It can be written as 18 into 10 to the power minus 3. So 18 into 10 to the power minus 3 divided by equation 2 is 2 into 10 to the power minus 3. This is equal to K. From equation 3 it is K 0.6 x into 1.0 into y divided by equation 2, that's k into 0.2 to the power x 1 to the power y. So k and k gets cancelled with one another. 10 to the power minus 3 and 10 to the power minus 3 gets cancelled with one another. 2 1s are 2 9s are 18. Then 1 raised to y, 1 raised to y gets cancelled. So we have 9 is equal to 0.6 divided by 0.2 to the power x. So using the laws of exponents, when we have a to the power m divided by b to the power m, I can write this is equal to a by b whole power m. So same law is applied here. So 0.2 divided by 0.6 divided by 0.2, that is nothing but 3. So we have 3 to the power x, which is equal to 9. So 9 can be written as 3 square. So 3 square is equal to 3x. So from the laws of exponents we have, when bases are same, we can equate the powers. And from this we can write x is equal to 2. This x is nothing but order of reaction with respect to reactant A. So therefore I can write order of reaction with respect to A is 2. Now similarly, we shall calculate order of reaction with respect to reactant B. Procedure followed is similar to that of how we have found out order of reaction with respect to reactant A. Now in order to find order of reaction with respect to B, from the 3 equations, we shall choose 2 equations such that concentration of reactant A is same in both the equations. So here if you check equation 1, 2 and 3, you see that in equation 1 and in equation 2, the concentrations of reactant A is same. So I will divide equation 2 by equation 1. So equation 2 is 2 into 10 to the power minus 3 equal to k into 0.2 raised to x 1.0 raised to y divided by equation 1, 10 to the power minus 3, and on the right hand side it's k into 0.2 to the power x into 0.5 to the power y. So 10 power minus 3, 10 power minus 3 gets cancelled with one another. On the left hand side we are left with 2. Right hand side k and k gets cancelled. 0.2x, 0.2x gets cancelled. Then we have 1.0 power y divided by 0.5 raised to y. Again using the laws of exponents, I can write 1.0 divided by 0.5 to the power y. This is equal to 2. So you can write 2 is equal to 1 by 0.5 is 2. So 2 is equal to 2 to the power y. 2 is nothing but 2 to the power 1. So from this I can tell y is nothing but it is equal to 1. So therefore order of reaction with respect to reactant B is 1. So finally I can write rate of the reaction as R is equal to rate constant K into concentration of A raised to 2 into concentration of B raised to 1. So therefore overall order of the reaction is 2 plus 1, that is equal to 3. So since in the question we are just asked with order of reaction with respect to reactant A and B, with respect to A order of reaction is 2 and with respect to reactant B order of reaction is 1. This method is very much lengthy. If such a question is asked in your competitive examination, you should save your time and you should be solving it very quickly in order to save your time. So I will tell you an easy method by which you can solve this question within a minute. These equations anyways you can interpret from the data table that is given. In order to find order of reaction with respect to A, we will consider two equations in such a way that concentration of B is similar. So if you look into the three equations, we find that equation 2 and equation 3 have common concentration for reactant B. So I am going to divide equation 3 by equation 2. Now when I divide these two equations, instead of writing the whole equation, I will neglect the common terms in both the equations. Anyway, they are going to get cancelled with one another. So I am going to neglect the common terms. So from these two equations, we have rate constant as common as well as concentration of B which is common. Rest of the things I will write. On the left hand side, we have for equation 3, it's 1.8 into 10 to the power minus 2, which is 18 into 10 to the power minus 3. Divided by equation 2, I have 2 into 10 to the power minus 3. That is equal to, right hand side on equation 3, it is 0.6 to the power x divided by 0.2 raised to x. Now I will simplify this. So right hand side, it is 0.6 by 0.3 which is 3. On left hand side I have 9. On right hand side I have 3x. So 9 can be written as 3 square which is equal to 3x, and from the loss of exponent I can write x is equal to 2. So we found out order of reaction with respect to A. Is equal to 2. Now similarly, let us find order of reaction with respect to B. Now here we shall consider two equations in such a way that concentration of A is same. So here we have equation 1 and 2 in which the concentration of A is same. So here I am going to divide equation 2 by equation 1. So when we do this division, I am going to ignore the common terms that's present in both the equations. So it is rate constant K as well as concentrations of reactant A. Other than that, rest of the things I'll write. So from equation 2, I have 2 into 10 to the power minus 3 divided by equation 1, that is 10 to the power minus 3. Right hand side, I'm left with 1.0 raised to y divided by 0.5 raised to y. Simplifying this, I get 2 is equal to 2 to the power y. 2 means 2 to the power 1. So from this, I can write y is equal to 1. And therefore, order with respect to B is 1. So this is how very easily you can find the answer. So instead of going through the traditional long method, you can use this method for your competitive exams. That quickly you can find order of reaction within a minute. The second question here is, for the reaction 2NO gas plus O2 gas giving 2NO2 gas, the initial rate of reaction was measured for different initial concentrations of NO and O2 as given below. What is the order of reaction with respect to NO and O2? So they have given us concentrations of NO and O2. Also rate corresponding to the different concentrations has been given to us. Task for us is to find order of reaction with respect to NO and O2. If such a question is asked for your competitive examination, follow the method I have just told you. Delete the common terms which are present in the equations we are considering. Consider only the terms that is required for us. Now we will follow the same method. For this given reaction, I can write rate law as rate is equal to rate constant K into concentration of NO raised to X, concentration of O2 raised to Y. So I'll denote this as star. Now this is my rate equation. Now from the given data, I can form 4 different equations. So 1, 2, 3 and 4. I'm not going to write these equations separately. So you can form this equation. So you can write rate is equal to rate constant into concentration of NO raised to X, O2 raised to Y. That is the rate law. Now, in order to find order with respect to NO, we have to consider any two equations such a way that concentration of O2 is same in them and concentration of NO should be different. So you can pick any two equations of your choice. If you check into the data that is given, you can see equation 1 and equation 2 have same value for concentration of oxygen. So these two equations you can consider. Also you can check that equation 3 and equation 4 has same concentrations for oxygen. So either you can consider equation 1 and 2 or you can consider equation 3 and 4 in order to find order of the reaction with respect to NO. Here I will solve by considering equations 1 and 2. So I will divide equation 2 by equation 1. So since equation 2 has higher value, I will divide it from the lowest value. So equation 2 by 1, I can write rates 0.384 divided by 0.096. That is equal to rate constant gets cancelled and concentration of oxygen gets cancelled. Then we need to write is the concentration of NO. It is 0.60 divided by 0.30 and these concentrations rise to the power x. Because in the rate law we have considered power of concentration of NO is x. Now is the simplification task. 0.384 divided by 0.096 is 4. 0.6 divided by 0.3 is 2 and this 2 rise to x. Now 4 can be written as 2 to the power 2, that is equal to 2x. Bases are same, so we can equate the powers and therefore x is equal to 2. X is now order of reaction with respect to NO. So order with respect to reactant NO is 2. In a similar way, now let us find order of reaction with respect to O2. What we have to do now? What we should be doing now is to consider two equations in such a way that the concentrations of NO is same in them. So checking with 4 equations, we see that equation 1 and equation 3 has same concentrations of NO. Either you can consider equation 1 and 3 or if you check with equation 2 and 4, they has same concentrations of NO. So I will consider equations 1 and 3. You can also consider equation 2 and 4, you are going to get the same answer. So considering equation 1 and 3, I am going to divide equation 3 by equation 1. So I can write 0.192 divided by 0.096, that is equal to rate constant and concentration of NO is same, so they gets cancelled. I am going to write only the concentration of oxygen. It is 0.60 divided by 0.30 and this rise to y. So 0.192 divided by 0.096 is 2 and 0.6 by 0.3 is 2 to the power y. 2 means it's 2 to the power 1. So from this I can write y is equal to 1. And therefore order of the reaction with respect to O2 is 1. So this is how we can easily find order of the reaction when concentrations of reactants are given. Third question. In a reaction between A and B, the initial rate of reaction was measured for different initial concentrations of A and B as given below. What is the order of reaction with respect to A and B? From the data that is provided to us in the question, we can frame three equations, 1, 2 and 3, corresponding to the rate law. So I can write rate law. Rate is equal to rate constant into concentration of A raised to X, concentration of B raised to Y. So from the first and second column, we have same concentrations of A, 0.2 moles per liter. Using equations 1 and 2, we can find order of the reaction with respect to B. Let's find it now. I shall divide equation 1 by equation 2. So left hand side, I consider rates. So it is 5.07 into 10 to the power minus 5 divided by 5.07 into 10 to the power minus 2. That is equal to equation 1. I have to just consider concentrations of B now. So it is 0.30 divided by 0.10 and the concentration of B raised to Y. Simplifying, on the left hand side we have 1 and on the right hand side we have 0.3 to the power Y. Sorry, it's 0.3 by 0.1, that is 3 to the power Y. So 1 is equal to 3 to the power Y. 1 is nothing but I can write it as 3 to the power 0, which is equal to 3 to the power Y, and therefore I can write Y is equal to 0. Means that order of the reaction with respect to B is 0. Now we need to find order of the reaction with respect to reactant A. Let us find order of reaction with respect to A now. Looking into the data table, we don't find any common concentration for reactant B. So from equation 1, 2 and 3, we can consider any of the two equations and we can find order with respect to reactant A. This can be done by considering any two equations because we have already calculated the order of reaction with respect to B. That is, we have found out the value of Y is equal to 0. So now I will divide equation 3 by equation 1. So I can write 1.43 into 10 to the power minus 4 divided by 5.07 into 10 to the power minus 5, that is equal to K and K anyway gets cancelled. So concentration of A is 0.40 divided by 0.20 raised to X, and that of B 0.05 divided by 0.30 raised to Y. So now we know that Y is equal to 0. 1.43 into 10 to the power minus 4 can be written as 14.3 into 10 to the power minus 5 divided by 5.07 into 10 to the power minus 5. That is equal to, since Y is 0, so if we have A to the power of 0, then this value is equal to 1. Similarly, we have 0.05 divided by 0.03 raised to 0, it is 1. So we have 0.40 divided by 0.20 raised to X. Let us simplify this. 10 to the power 5 gets cancelled with one another. We are left with 14.3 divided by 5.07. That comes out to be 2.8. On the right hand side, 0.4 by 0.2, that is 2 to the power X. Now in order to simplify this, we cannot write 2.8 as 2 to the power something. So we shall consider log on both sides. So log 2.8 is equal to log 2 to the power X, which is X log 2 is equal to log 2.8. So the value of X is equal to log 2.8 divided by log 2. Instead of finding log 2.8, you can consider this as equal to log 3. So log 3 divided by log 2, which is equal to 0.477 divided by 0.3010, and that is equal to 1.58. So this is how you can find the exact answer. Now if you are provided with answers in the multiple choice format, then you can directly find the answer from this, because you will be provided with the options like order of reaction with respect to A is 1, 2, 1.53 or something like that. So you know 2.8 is equal to 2 to the power x we have got. So if we have this value as 2 to the power 1, it means that order is 1. If we have x value as 2, then this value would be equal to 4. If x value is 2, then the value that we should be getting with respect to 2x is 4. So now the value 2.8, it is lying between 2 to the power 1 and 2 to the power 2. And therefore, order of reaction is between 1 and 2. That implies order of the reaction is approximately 1.5. So this is how you can estimate if you are answering a multiple choice question. I hope you will find this method very useful with respect to your competitive examination. I'll meet you in my next video with another trick. Thank you for watching. Stay connected, keep learning, take care, bye-bye.